Good afternoon, everyone. Welcome back to the course Natural Language Processing. And today we will learn on chapter 10. It is about name entity recognitions using TensorFlow. And this is the outline in this lecture. We will briefly talk on the introduction to NER, which stands for name entity recognitions, and we use TensorFlow. And next, we will see on how we can perform NER using TensorFlow. So now we will talk on the introduction to NER. What is NER? It is an information extraction technique that is used to identify and classify name entities in the text. So when we refer to name entity here, we are referring to common nouns appearing in the text, such as locations, organization, persons, dates, times, or so on. So these information are represented in the text, which give us some information describing some action or locations or address in the text. And as we can see in the current technologies, Gmail is using NER to add date or time in the email for letter notifications. For example, when we write an email to somebody and then we mention some times inside those email, basically the Gmail will add those date and time to our calendar for letter notifications. And there is one more case. For example, when we write some text in our email, that we attach some documents. However, we forgot to attach those files or documents when we send the email. So when we click on send, Gmail will be automatically remind us that we forgot to attach the file. So this kind of application which was implemented using name entity recognition. And the three main approach to make NER system, like the first one is classification approach, and second one we use a machine learning approach, and lastly we have deep learning approach. So each of these approach they use different methods to achieve the NER system. And next we will see on the use of NER. The first one is classifying content for new providers. As we can see that in the news there are many thousands of articles. So for a user, they can scan the entire articles and they want to know what information are discussed in each article, such as people, organization, or places. So to achieve this, NER can help us to classify these kind of contents. The next use of NER is to have an efficient search algorithms. As we know that in the Google, when we search some things, there are many resources are available on internet or online. So we need to make it faster as we can. So from this, with NER, it speed up the search process. When we obtain the relevant text, or we call it entities, in all the articles which are stored separately using NER. So from NER, we can extract those entities into the documents and then we can later search it from those information. Next, powering content recommendations. With NER, it can help to automate the recommendation process by matching the most similar text together. Obtaining from the contents, we can extract common entities. From those entities, we can later recommend based on user keywords. And the fourth one is research in the research papers. For NER, it can help to categorize data to a well-structured form so that we can extract particular information more easier. So from this case, we have different types of category data. But when we search, it will need to search from each of the data, right? So from here, to avoid searching all information in the data, we extract some important name entities so that when a user want to search, we can actually checking with those extracted entities. And next we'll see on how we can use Neuro NER, which is a part of tool implemented using TensorFlow. So Neuro NER is a program that performs NER. It is based on neural network. So from name entity recognitions, it identifies entities of interest such as location, organizations, and some other important information. So from these identified name entities, we can use those features in machine learning systems, or we allow them to perform NLP tasks. And some command application of identifying name entity can be used in patient node de-identification. For example, we have a record of patient. There are many thousands of patients which the information can be stored electronically. So when we want to search some specific information on a particular patient, we can use some key term, and then by using NER system, it can retrieve those related documents. And the advantage of neural NERs over some existing NER systems, it enables user to create or modify annotations for any new or existing data, or we call it corpus. And neural NER, it is a cross-platform. It is free and open source, which is also straightforward to use. It is easy for any type of developers because the tool gives us some straightforward features. And this is an overview of Neuro NER. We have the input, which is a piece of text, a piece of articles. And from the Neuro NER engines, it's process those information, and as the result, it gives us the touch entities appearing in those information. For example, in this case, we see some names like Edwina Curry, which is a person, and we have another person name. It is called Clark. So from this simple sentence, we know who is mentioned in this article. And next, we see on how we can implement NER using the neural networks on top of Neuro NER. So in here, we need to install some related library. It is also based on different type of our machine, whether we have the GPU support or we run only on CPU. As we know that if we have GPU's specification, it can help us to run the performance much faster. So to install Neuro NER using simple CPU support, basically use pip3 install and then Neuro NER and specify the CPU in the bracket. But in case that we have GCPU support, we can just replace the CPU to GPU. So this command will allow us to install the Neuro NER, which is built based on top of TensorFlow. And we may also need to require some other package. So to download that, we use Spatie module here. So you can type Python's Spatie download, and it is a language which is written in English. So those information can be obtained by specifying the EN's shortcut. And the requirements to run Neuro NER, we require TensorFlow because Neuro NER, it uses TensorFlow for its engines because its engine is built on top of neural networks. And for programming language, we require Python 3. We cannot run on Python 2. And we may need some additional tools like Brad. It is an optional. We can install it, or we can just leave it there, which is a web-based annotation tool, which helps us to annotate the text more visually. And this is the visual document to Brad. We can see more detail in this link. And next we see the steps which are used in Neuro-NEO. There are 3 main steps. The first one is training, second one is evaluation, the third one is deployment. So in the training, we train the neural networks that perform the NEO. So to train this one, we need to specify a specific model to be used. And next, during the training, Neuro-NEO, it allows us to monitor the network. So we can see that how performance is going or how the data is obtained from its process. And next, in the evaluation process, we evaluate the quality of the predictions which is made by Neuro-NEO. And next, we can check the performance metrics by calculating and plotting the informations comparing to the predicted labels. And we have the predicted labels and we also have the actual labels because it is in supervised classification. And in the third main steps, deployment, we can deploy the Neuro-NEO for any production use. And in Neuro-NEO, it labels the deployment sets. So we have the new input data, which we don't know the actual labels. So by using Neuro-NEO, we can obtain the predicted class labels for this new input data. So in the train process, we require some data sets. We divide into training set and validation sets for using to train and validate the model. So once we prepare the training and validation sets, we can use it to fit into the Neuro-NEO engines. And based on Neuro engine, it gives us the output which we can visualize. We can see how it performs. We can see its learning case, how it trained the model, and we can use TensorBoard graphs to inspect, to visualize its process in the training part. We will later talk about TensorBoard more detail in the next following slide. And next, to evaluate the model in the Neuro-NEO, we require some input test sets. So this is not the same to the training set and validation sets. We need to have different data so that we can see how well our model can perform. So from the Neuro engines, we can see how the result can be obtained with the confusion matrix as well as the classification reports. So in classification reports, there are several types of evaluations metrics such as precision, recall, and F1 score. And the output from the evaluation, we get the test set with the predicted entities. For example, we give this input, and as a result, we know what is the information representing in this input. For example, we have the person name Adam, and we have World Cup, which is an organization, and we have also these information like the location and organization appearing in this sentence. Lastly, in the deployment process, we require some input data, like we call it deployment sets, which is used to fit to our model. So as the result, we obtain the predicted entities, which is obtained from the models. And these outputs give us more data to generalize our model. And this slide gives you some important commands, how we can load the data, prepare the data, create model, as well as train and evaluate our models. So to download some word embedding, we can use these commands using widgets. And then we can extract this information using the unzip command. And next, if you want to load dataset from command line, we can simply run this Neuro-NEO command. And in addition to the command line, we can also load the dataset from Python interpreter. So in this case, we need to write the piece of Python code into the Python source files. So from Neuro.neo, we import the Neuro model, and next we can load some related datasets to be used. And to load the pre-trained models, we can use this command, fetch model. So in Neuro.neo, there are some already pre-trained model. We can just simply use them. So it gives us a specific classifier to be used in our training process. And next, we can use the Neuro.neo after we specify the Neuro models. So from this, it gives us an ability to train our model. Next, we will talk about the TensorBoard. So what is TensorBoard? It is a tool which provides the visualization and tooling needed for machine learning experiments. So during the experiment, we can inspect, we can see the process which is taken, which is implemented during the training and evaluations. So from TensorBoard, it gives us some information such as scalas, which gives us the accuracy or the loss information appearing during the experiment, and it represents as a graph here. And we have the image, how for each step how the image can be classified in case of image processing. And we can also visualize the graphs for each process in the neural network. And we have the distributions as well as the histogram to represent the image, how it is classified. For example, this image can be obtained using different types of data transformation. So why we need TensorBoard? It allows us to track and visualize metrics such as the loss and accuracies, as we saw in the Scalia Scalia features. And we can visualize the models, graphs, as well as to view the histogram of weights and some other information over a period of time. And we can also project embedding to a slower dimensional space. Next, we can also display image, text, as well as audio during the experiment. And lastly, we can profiling the program of TensorFlow. And here's the homework for this lecture. You can install the TensorBoard and then try to play around on how you can see the visualization of a specific model. So in here, you can use any selected model. And next, try to find some existing application of NEO, which is used in NEO, like we see in Gmail. They have the application in Gmail which detects the date and times whenever we mention in the email body. So those date and time can be added to our calendar for later notifications. So there are many other existing applications. So you can try to find and list some of them here. Okay, thank you for today, and we will see you in the next lecture. Thank you.